The idea of exponents, one of which, if you have, let's say, x to a certain power, this is saying how many times something is being multiplied. That's the idea. How many times are we multiplying? Okay? And when we think of something as opposite, and we're talking about multiplying here, how many times is something multiplying? Okay? If we were to give a variable with a negative exponent, okay, we're looking at something as far as how many times it's being divided, right? And the idea is what they call a multiplicative inverse. So if you have x raised to a negative power, raised to a negative nth power, it's basically you're saying, okay, not how many times am I multiplying this variable or this number that's represented by the variable, but how many times am I dividing? Now, let's look at some basic rules with exponents. One being, if I have variables with exponents and I'm multiplying, and we have a like base here, essentially what we're doing here is we're adding these exponents. And again, if I have two different variables here, then no, I can't combine what I'm being given from my exponent. Right? Here would be x to the 7th. So we want to look at some examples. Let's say we look at something as far as x3 times x to the negative 5. Let's just look at something like this here. And what this is telling us to do is that essentially we're adding that negative 5. And we know we end up with x to the negative 2. Here we have a negative, it's raised to a negative exponent, so basically this is an inverse. We're dividing by this number however many times. Okay? So an example of that would be kind of, I'm dividing whatever's on top, let it be a 4, I'm dividing by 2 twice. That's the idea here. 4 over 4, 1, let's say. Now think about that. You're dividing by 2 twice. I think that's it. 4 divided by 2 is 2. 2 divided by 2 is 1, and that's the idea. This is how many times you're dividing by that number. Now you may end up with certain cases where you're given let's make this a y. Say we're given something like this. Here we have two different variables with exponents. Basically what I like to do is look at, okay, I'm doing negative 4 plus a negative 3, where my y is a negative 5 plus an 8. And I'm simplifying here. X to the negative 7, y to the positive 3. Now, are we finished here? No, we have to do a little bit more evaluating, and the idea is, okay, here I'm multiplying this number 3 times, so we'll keep this as a numerator. Here I'm dividing this number by 7 times, so actually it makes its way to the bottom. And that's multiplying, dividing with negative exponents, mainly with variables. Yeah, you can end up with, let's say, some numbers with a similar base, and end up with a 3 to the negative 8th, and then you would have 3 to the 8th. This becomes something that you can very much use a TI-84 and evaluate and see if you're getting something to match. Variables, not so much. Next thing we want to look at, we're looking at questions? I'm gonna erase this. Yeah. Where is this? Oh, here actually it'd be 9 to the negative 8th, right? Would it be like this here? Is that what you're saying?
So
Is that the idea? Or are you saying, like when we multiplied x times x, we were evaluating, let's say we have x to the first, this is x squared, right? So here, you're multiplying by a similar base. So, are we multiplying so much the number or base here, or are we more so looking at the exponents and evaluating that? So, actually, we would keep this, keep this 3 to the negative 8 here, and then evaluate. No, you're not. You're not. Yeah, we're just looking at the base and evaluating.
So the base number is the same.
Base number's the same. That's it.
So it's already.
Yeah, if you have different base numbers, let's say you're working with another example here, and you're working with different base number. 4 to the, let's say just 4 squared times 3 to the negative third, right? You would actually have to evaluate this Amherst as 16, and then times 1 over 3 to the third, which would be 16 times 1 over 27. And you would end up with a 16 over 27. This is where you would actually evaluate the numbers before you added the exponents. Cameron?
You have x negative 7, x to the power of negative 7, and y to the power of 3. When you put y to the power of 3 on the top.
Like this here?
Yeah, why does the y go on top? Did you have y?
Well, this is, again, we're saying that any variable raised to a certain power, you're saying how many times that variable is being multiplied, correct? So, essentially, you're saying y times y times y. The reason we're putting this on the bottom is because it's an inverse. It's to a negative power. So, we're saying by how many times this number is being divided, set, let's say, x to the 7. So, I mean, we can, do I have 7 there? Here we have 7, y to the third, x to the 7th. Yeah, why would you, Cameron, if you had like 5 to the third, you would say, okay, that gives me 125. Why would you make this 1 over 125? Why would you take this when it doesn't have a negative exponent and put it on the bottom? The whole idea is that x to a certain power is multiplication, so the inverse of that, a negative power, would be the opposite of that. Yeah.
So, for like the negative exponents, it doesn't matter what they're under. Like when they go on the bottom of the little fraction mark, they become positive.
Yeah, if you have a variable like this, right? And your understanding is that this is an inverse. You're basically switching it from multiplying to dividing, correct? So the idea is that yes, once you bring it to the bottom, the exponent becomes positive.
I was about to say it doesn't have to be under 1 because it's under the y and it's being positive over there. So I'm just it doesn't have to be.
This here?
Yeah, because it was x to the negative 7, and then you put it on the bottom. It just x to the 7.
Yeah, when you're evaluating a scenario where you have 2 different variables, and you end up with the y to the third power on the top. Yeah, your understanding is that the variable here, y to the third, is basically your top part here, where your 1 is. I don't have anything in this example to take the place of my numerator, so I say it as a 1. Okay, or we say it as a 1. Where here, I have something that's taking the place of the numerator. I could say 1y to the third over, but there's really no purpose to that. Do you understand that?
Yeah.
Yeah, see, if I have multiple x to the negative third, z to the fifth, y to the negative 2, w to the third, I would evaluate this as z to the fifth, w to the third over x3, y2. Both my variables have been brought to the bottom. And this is, yeah, Amherst?
So if you have two different variables and one has a negative exponent, that exponent always goes in the bottom.
Yep. You can write that down as a note. Are we good on this?